All right, in Chapter 9, we're going to dive into what do we do if we have two populations to compare. And in 9.1 and 9.2, we're going to look at proportions specifically. So in 9.1a, we're going to estimate a difference between two proportions. Okay, so first of all, we have to talk about what does that distribution look like when you subtract two numbers. Okay, so if you remember before when we did sampling distributions, we talked about shape, center, and spread. Okay, all three parts we have to know in order to use a z-score or a t-score, right? So we're proportions, so we're focusing on z. We need the shape to be normal. We have to know what the center is, and we have to know what the spread or the standard deviation is in order to do all those calculations. So how do you calculate it when you have two proportions to compare? All right, so here's what you're going to do. The shape, here's what you need to know. The shape of the sampling distribution of p hat 1 minus p hat 2 is approximately normal if, look, n1 times p1, n1 times 1 minus p1, this is large counts test, guys. You do large counts test for the first proportion, then you do the large counts test for the second proportion, and they all have to be at least 10. If you show those two things, then you know the shape is normal. To find the mean, you simply subtract the two proportions, okay, the two sample proportions, and pretend that those are the real proportions. That's all you got to go on, so that's what you do. To find the standard deviation of the sampling distribution, you use this formula. Notice that if you just look at this piece right here, it's what we used before with proportions. We just have to add on the second proportion, all right? So don't get overwhelmed, just take it in pieces. Now, we've learned two conditions that have to be met before you can construct a confidence interval for a population proportion, random and large counts. Now that we're comparing two proportions, we have to modify these just slightly, okay? So to get random, you have to show that the data come from separate, notice it's separate random samples from the two populations of interest or form two groups in a randomized experiment, okay? You just have to show that they're separate samples, okay? And they're both random. So you have to say simple random sample of n size equals whatever 2 times, that's all. Large counts is what we just talked about, okay? Counts of successes and failures in each group. That's what we just did. We just have to show it for both groups. So it's kind of double the work, but it's not difficult work. All right, let's try an example. Okay, on example 1, candy maker offers child and adult-sized bags of jelly beans with different color mixes. The company claims that the child mix has 30% red jelly beans, while the adult has 15% red jelly beans. Assume the candy maker's claim is true. Suppose we take a random sample of 50 jelly beans from the child's mix and a separate random sample of the 100 jelly beans from the adult mix. Let P1 be the adult sample proportions of jelly beans and P2 the children's sample proportion of red jelly beans. All right, so A says, what is the shape of the sampling distribution of P1 minus P2? So we need to know, is it normal? How are we going to know? Large counts test. So let's identify. P1 is the adults, right? And it tells us that the P1 percentage up here is 0.15. And we know our sample size for adults is 100 because it tells us this right here. So I'm going to do large counts test. 100 times 0.15 is 15. That's greater than or equal to 10. Then I do 100 times 1 minus 0.15 gives me 85. And that's greater than or equal to 10. So the adult side is good. P2 is the children proportion of red jelly beans. And they tell us that that, up here in the wording, is 0.30 or 30%. My sample size for children was 50. So let's run large counts. I have 50 times 0.30. That gives me 15, which is greater than or equal to 10. And then I have 50 times 0.70, which is 1 minus 0.30. That is 35, which is greater than or equal to 10. So what is the shape? The shape is approximately normal, and it's because both proportions pass the large counts test, okay? Find the mean of the sampling distribution. Well, if you remember the previous slide, to find the mean of P1 minus P2, you just simply subtract P1 minus P2. That's all you have to do. So P1 was 0.15 minus P2, which was 0.30. Make sure you do them in the correct order that was given. So I get a negative 0.15. You can have a negative mean, so don't let that trip you up. Just follow the order that they tell you they are, okay? Now in part 3, it says calculate the standard deviation of the sampling distribution. So again, what is P1? P1 was the adult, so P1 was 15%. P2 was 30%. That was the children's percentage. So now I'm going to plug things in. My sample size for the adults was 100. My sample size for the children was 50. And so I show my work. So 0.15 times 1 minus 0.15, all of that over 100, plus 0.30 times 1 minus 0.30, all of that over 50. So be careful when you're putting it in your calculator. There's a lot of places you could mess up, but don't let it. Just take it step by step, and you'll get it just fine. All right, so I put it all in my calculator. I did it step by step, and I come up with a standard deviation of 0.208. Okay, that's the standard deviation of a sampling distribution of the differences of these two proportions. All right, so in your homework, that's what you're going to be asked to do. You're going to be asked to figure out the shape, figure out the mean, and figure out the standard deviation of a given situation with the difference of two proportions.